Alright, this is a part 3 of Engineering Statics Exam 1 review. We're going to be going over problem 2.102. Feel free to go ahead and read the book ahead of time and get all of your givens and your finds ready for it, and we will start off to going into the problem. The problem states that 3 cables are used to tether a balloon as shown. Knowing that the balloon exerts an 800 Newton vertical force at A, determine the tension in each cable. So we're going to go ahead and jump right on into it. You're going to start off, the way I like to do it, I just kind of start off with going through alphabetical, so I'm just going to find tension AB first, which you need to break it down into I, J, and K components. So for tension AB, we're going to have a negative 4.20 in the I. We're going to have a negative 5.60 in the J, plus 0 in the K. The J direction is negative because A is our point of interest, and we're going down to the tether points. Therefore, we are going from top of A down, it becomes negative. I'm going to go ahead and do the lambda step, which is taking the sum of the squares. I won't let y'all do that, but the method for that will just be sum of the I squared plus J squared plus K squared components. Solving it out, you get lambda to equal 7.00 meters. Tension AC, we're going to have a positive 2.40 in the I, minus 5.60 in the J. This one's going to have a K value of 4.20 K. Lambda AC will come out to 7.40 meters. Last one, tension AD. We have nothing going on in the x direction, so we start off with the y, negative 5.60 in the j direction, and we have a z component of a negative 3.30 K. Lambda AD will come out to 6.50 meters. Now that we have our tensions in component form and our lambdas, we can go ahead and break it into x, y, and z components and the forces. So the forces in the x, forces in the y, and the forces in the z. So we'll start it all off, and tensions in the x direction, tension AB times negative 4.20 over 7, tension AC, which will be 2.40 over 7.4, and tension AD, and it's got nothing in the x direction, so it's going to be 0 over 6.50. This all equals 0. Now, do we have a force acting in the x direction being caused by the balloon? Well, as stated in the problem, we have an 800 Newton force in the vertical at A, so that is acting in the y direction, therefore we have nothing else acting on it, so it will be 0. Go into the y direction, label it again for tension AB. Scroll down so I can see what I'm looking at. We have a negative 5.60 over 7, tension AC, which will be negative 5.60 over 7.4, and tension AD, which will be negative 5.60 over, 6.5. And now we have the vertical force at A, so that is a plus 8, make that a little better, plus 800 newtons, all 0. Go ahead and do everything in the Z. Start off at AB again, stay consistent, this will help you for your matrix. In the Z direction on the AB, we have nothing going on that there, so 0 over 7 plus tension AC, which will be 4.20 over 7.4, and tension AD, which is a negative 3.30 over 6.5 is equal to 0. Now you have your unknown tensions at TAB, AC, and AD all set up and ready to go for either discriminant method or matrix method. Discriminant method you can do if you think you have the time for it, but it is very time consuming and will take a lot of pages of work. So the easiest way to do is put all of this in matrix and solve. So for the matrix, we have tension AB, tension AB, tension AB, and you just plug in exactly what you see from the sum of forces in the X, Y, and Z into the matrix. The only difference, is that on your other side you're going to have a negative 800 newtons. This way you have something to actually do your inverse to for the other side, so you actually will get your tensions to come out. Your tensions will come out of tension AB, AC, AD. I'm not going to show you how to input it into the matrix because at this point you should already know it from your previous calculus and algebra classes. If you have any questions on input for the matrix, go ahead and ask me or Jackson before the exam, but during the exam we are not allowed to show you how to put in the matrix. We are on the assumption that you already know this. With that being said, tension AB comes out to, let me find my place here, I'm sorry, 201 newtons, tension AC, 372 newtons, and tension AD is to 416 newtons. This one is a really good problem to study for the exam. He loves these kind of problems, so watch your process through it really. As long as you get all of your X, Y, and Z and your I, J, and K components all put in the right format, put it into the matrix correctly, you will get the answers just fine. Keep in mind that for the exam, he's looking more at if you know how to solve the problem, not if you get the correct answer. So even if you do all this work and you don't come out with the right answer, as long as you show your work fully and correctly and logistically, he will give you most credit. The next problem that was on the list is problem 2.104. That one is one of the problems that I'm suggesting. It is a problem that is a hanging weight. That means that your force is going down at A, so it's all hanging. This problem is really good to study. I'm not going to go over it. I'm going to let this one be as a self-taught one because you've done it on your homeworks. Jackson recommended me more on doing 102. He said that one's going to be very similar to what's probably going to be on the exam. But know how to do problem 2.104 in case he puts a hanging weight instead of a balloon. The only difference between 2.104 and 2.102 is simply what direction your force is going. So in the balloon, you have a positive x because it's going up. Hanging weight, your weight is going down, so you're going to have it as a negative value. Other than that, stay tuned for Chapter 3 lecture for review in Part